Assalamualaikum warahmatullahi wabarakatuh. My name is Hafizul Fahim bin Mohrofi. I want to present our project for digit password by using STM32. Okay. Okay, for our project, uh, we use 5 push button to be represented number 1, 2, 3, 4 and 5. Okay, the user must enter 4-digit password that have been configured. If the password is right, um, the machine will the machine will turn on green LED. If the entry password is wrong, the machine will turn on the red LED. If the user miss 3 times or make the same mistake where the user put the wrong password in 3 times, the buzzer is triggered. The component that we use for prototype 4-digit password using STM32 is 5 push button, STM32 board, red LED and green LED, and last but not least, buzzer. Okay, for block diagram, the input for our project is 5 push button where represented 5 number is number 1, 2, 3, 4 and 5. Then it will enter the STM32 and the output is will display on LCD. For example, if the password is right, the green LED will on. But when the user put the password, miss the password or put the password wrong in 3 times, the red LED will turn on. Then the buzzer will trigger. Okay, for the flowchart, the user must insert 4-digit password. Then, if password is correct, the LCD will display password correct and green LED on. But if the password is incorrect, LCD display password wrong and LED and red LED on. Then the user need put back the password until the 3 time. But if more than 3 time, the LCD stay display password wrong, red LED will on, but the buzzer will on. Okay. For the result by Proteus and the kill, I will put it on my next video. Okay, for the coding part, for the line 1 and 2, we want to declare we want to use STM32 board. And for the line 4 and 5, we want to declare that we use LCD display. For this part, we want to say this is LCD command, LCD data, and delete MS. Okay, then for this part, we want to declare push button as input. since we use 5 push button, we declare it as push button 1 as PB, PB1, PB2, PB3, PB4 and PB5. For this INTZ, we want to use update cursor position. For this line 21 until 26, we want to declare message as each char. For this line, we want to enable clock GPIO-A and GPIO-B. Okay. For this part, I want to enable output and input pin for LCD and the PB. For GPIO-B, I use all the lower input, and for GPIO-A CRL, it just only use 2, which is EN and RS for the LCD display. GPIO-A CRH, I used to enable 5 input, which is from the port 8. Okay, then for this part, it used for LCD initialization command, and we set cursor 0 at line 1 for the LCD command, which is it 0 times x0. Okay, I forgot. For this line, we need set cursor 6 at line 1, which is initialized from the line 19, where it initialize 0 times 06. Okay, we back to our looping. Okay, for this looping, when we enter PB1, it will display the char A, which is it represented with 1, and it will update the value for a cursor position, where it z plus 0 times 01. Same with PB2, it will display char B, which is represented by number 2, and it will updating z value for cursor position. This progress, we're looping until the PB5. Okay, for the references of the char, we need go back to the first coding before, where we set char A as 1, char B as 2, char C as 3, char D as 4, char E as 5. And then it will display in this looping. After this loop, we will use this LCD command, LCD data, and delay ms to know our to know the ending of our coding. And then when we finish our coding, we need to try run and know whether our coding have error or not. Okay, when we run, there has no error and no warning in our coding, and we will pass this coding to our next simulation in Proteus. For the Proteus simulation, we declare PB1, we declare push button 1 as number 1, PB2 is number 2, PB3 is number 3, PB4 number 4, and lastly PB5 is number 5. All these push button will connected to the port from PAX until PA12. Then for LCD display, VSS, VEE, and RW will connected to the ground. VDD will connected to VDD. RS will connected to RS, and E will connected to E. We connected to EN, where EN will connected to the port PA7. Then D0 until D7, we connect to the PB0 until PB7. Okay, for simulate this Proteus with our coding before, we need to double click to STM32. Then we run our simulation. We click PB1, PB2, PB3, PB4, and lastly PB5. That's all for me. Thank you.